Welcome back, learners. So now, as we have said before the ad break, we're moving on to our application questions, and they are still based on the reflection of light. Now, the first application question that we have requires us to draw and also label a ray diagram to illustrate the reflection of light. So draw a labeled ray diagram to illustrate the reflection of light. So we know that with every ray diagram that we draw, we always need to have a surface so that that surface can reflect the light, so that that light can go to the observer, being the eye or being whoever is trying to see something. So if we start with our surface, our reflective surface, this is our surface. Remember, we need to label it. Now, we have now the light coming from the source. And remember, if the light is coming from the source, it needs to be shown by the arrowhead to show the direction. So if our source is now the candle, how do we draw the candle? Let's do this. Yeah, let's do that. So if the light is coming from the source, in this case being the candle, this is going to be known as your incident. That's going to be our incident ray. Now, this light coming from the source is going to bounce off the surface. It is going to be reflected off this reflective surface. And then, if it is reflected off the surface, this ray will no longer be called an incident ray, but will be called our reflected ray. This is going to be called a reflected ray. Right, so this is going to be the observer. This is going to be the eye. Yes, going towards the eye. Then remember that in between the two rays, in between the incident ray and the reflected ray, there needs to be an imaginary line that helps us to measure the two angles that you're also going to be talking about on this ray diagram. That line is called your normal. So it is called a normal. It's drawn using the dotted lines, and remember, it makes an angle of 90 degrees with the surface. So this line helps us to measure the two angles. We have the angle of incident here, that is going to be in between the normal. So this is our normal. This is our normal line. So the angle of incident is going to be between the normal line and the incident ray. So we can denote that by small letter I to show that this is our incident angle. Then the other angle here is going to be between the reflected ray and still the normal. So this is going to be denoted by small letter r. Let's write our r nicely. So it's going to be denoted by small letter r. And remember that the angle of incidence is always equals to the angle of reflection. So this is going to be our ray diagram to show the reflection of light coming from the source. That ray is called our incident ray. If it bounces off the surface, being a reflected surface in this case, it is going to be called a reflected ray. Then the line in between the two rays, the incident ray and the reflected ray, is called our normal line. That line is always perpendicular to the surface, hence the 90 degrees angle there. And that line helps us to measure the two angles, the angle of incidence and also the angle of reflection. Now we also have our surface, as we can see on this particular drawing, and the labeling. So now moving on to the next question. The question is asking us, why are reflections of rippled water not clear, but rather blurred? So the reflections that we are seeing on the rippled water, they are not clear, but they are rather blurred. Why does that happen? So this happens because the light rays have not reflected parallel to each other, as they do from a smooth surface. Remember, we can either have a smooth surface or a rough surface. In a smooth surface, the light rays are going to be reflected parallel to each other. However, on a rough surface, those light rays are not going to be reflected parallel to each other. However, they are going to be scattered in different directions. And because they're not parallel and they're scattered in different directions, the image formed there, or the reflection that you're going to be seeing there, is not going to be a smooth or a specular image. It is going to be a diffused image or a diffused reflection. Remember, we have a surface. If it's smooth, we have light of incidence or incident ray coming, and then we also have the reflected ray. Now, if we can have multiple incident rays on a smooth surface, all of those reflected rays are all going to be parallel to each other. Remember, by parallel to each other, we're meaning that they are next to each other. They will never touch, they will never meet anywhere. So this ray will never touch this ray. This ray will never touch this ray. They will always be next to each other at equidistant away from each other. However, if the surface was a rough surface, now when this happens, the light rays, when they are being reflected off the surface, they're going to be scattered all around the space, and because of that, they will not be parallel to each other, meaning that at some point they're going to intersect. That means they're going to cut each other, and that is not supposed to happen. And when that happens, it causes that blurred image, not a smooth image that we are seeing or that we may want to see. However, if this surface was to be smoothed out, or if this was water and this water was still and not moving, was a smooth, a quiet water, then we'd have a smooth surface. And when that happens, all of the incident rays were going to be reflected parallel to each other, and they would give us a specular image or a clear image. However, they are not giving us a clear image because the surface, it is rough, and if it's rough, they're giving us a diffused image or a diffused reflection. So our next question is asking us, it is saying that white light consists of a certain number of colors, and we need to name the colors in order of increasing frequency. So the white light, remember, sun gives off white light, and that white light is a combination of 7 different colors. So the answer to the first part of the question is 7 colors. Now, those colors that are coming from the source, being the sun, that are giving us the white light, what are they? Remember, you always need to think of the Rooikweight. Now, those colors, or this Rooikweight, it is arranging our colors in order of increasing frequency. So we have the red, we have the orange, we have the yellow, we have the green, we have the blue, we have the indigo, and then the last one is our violet. Remember, as we are going from red, going all the way down to violet, we are increasing in terms of frequency. And if you are increasing in terms of frequency, that means the wavelength of these colors, it is going to be decreasing. Because the relationship between frequency and wavelength is that when one increases, the other one has to decrease. If wavelength is increasing, frequency must decrease. If wavelength is decreasing, frequency must increase. In this case, frequency is increasing, so therefore the wavelength is decreasing. So we have talked about, we've drawn a ray diagram, we have labeled a ray diagram, we've also talked about the 7 different colors that we're finding from a white light. We've also now arranged those colors in terms of the increasing frequency. We can also do the very same thing. If we were to arrange these colors in terms of increasing wavelength, we'd start from violet going all the way up to red, because as you're going up from violet to red, we are increasing in terms of the wavelength. Now, we've also given reasons why we can either have a diffused image or also a smooth or a specular image. This is because of the 2 different surfaces that we can have in any scenario. And with those 2 surfaces, we are able now to draw a ray diagram to illustrate what really happens and why do we have a diffused image, and also why we also have a smooth image. So before moving on, we're just going to quickly go for a short break, and I will see you just after this.